All right, welcome to algebra.com.au. We are going to go over the Silly Mistakes Killer PDF. If you're watching this on YouTube or Instagram, and the link is either in the bio or it's going to be underneath the video. And this is going to be a very quick video. I'm going to try to keep this under half an hour. And the idea is we're going to go over this little PDF, right? It's about 30 or so pages, and there's like another 100 or so pages for the answers. And we're going to pretty much go over all the algebra you need till year 12. There's like some topics missing here and there, but it is going to set the foundation of whatever you'll need. So maybe some formulas first. Let's actually, before we get into everything, the things that you need to know for this PDF at least, right? It's designed to kill your silly mistakes, right? It's not designed to go over every single aspect of algebra, but the most important ones and the ones that reoccur often and often. So we have index laws, obviously, right? So we're going to start with indices first. Let me change this up. So we're going to start with indices. Then we're going to move on to expansion. Actually, I'll just show you guys. Why not? You have indices here. Then we're going to move on to some expansions. Then we have factorization right after. Let's keep going, keep going. We have some factorization. Once we're done with that, we're going to move on to, I believe it's surds, more factorization, algebraic fractions, and then it's surds. And then once we're done with that, then we're going to move on to simultaneous equations, and then that's pretty much it after inequalities. Yeah. All right. So big PDF. I'm going to probably go through 1 to 2 questions every single part so that you have an idea. So when you're practicing this on your own, you know exactly what to do. So let's start off with like actually knowing some laws, right? What are all the index laws, or the main ones that you need to know, at least the ones that come up very often that you probably make silly mistakes in a lot. And to kind of set the tone here, algebra is a language of maths. If you don't understand algebra, like, you're going to struggle with everything. I can make any question hard by adding algebra to it. Like, let's give you one right now. If I was to give you a triangle and the sides were 3 and 4 and it was right angle triangle, you know you have to use Pythagoras theorem, right? So you go, okay, that's just going to be the square root of 3 squared plus 4 squared, which is 5, right? Like the working out, if let's just say the hypotenuse was y, it would be 3 squared plus 4 squared square rooted, right? Which is 5. And then, let's say the sides were no longer this, right? Why is the rubber like that? Let's say the sides were no longer this, but this time it was something like the following. It was like x plus 1 and then x minus 1. Now, mind you, this is still Pythagoras theorem. We haven't changed the topic here, right? But this time, y squared is going to be x plus 1 whole squared plus x minus 1 whole squared. Now that's a whole different question. This is like a 3 marker or a 2 marker at least, compared to like the previous one, which is like maybe a 1 marker. And this simplifies to, if you expand it and simplify it, it'll be like 2x squared plus 2 and then square rooted and then Bob's your uncle. Now, this is actually 3 lines of working out. Now, I skipped a line because I can. And this actually gives you y squared is equal to x squared plus 2x plus 1 plus x squared minus 2x plus 1, right? And then it simplifies to that. And you can apply this to any topic. Like, I can make probability harder by adding algebra to it. I can make statistics harder. I can make any question harder just by adding algebra to it. So that's the idea here. Like, algebra is very likely your bottleneck and what's preventing you from getting marks above 90-95%, because if you're getting marks around 80% and above, then usually silly mistakes is like a big chunk, right? The hard question might be like 10%, maybe 5% of your exam, but algebra is the big chunk. So we are going to try to go over everything like you need for algebra and try to get rid of your silly mistakes, okay? Starting off with, we have indices, right? You have some index laws that you have to know. You know, if you have anything to the a to the power of n times a to the power of n, as long as they have the same base, you add the powers. If they have a different base, then you minus the powers. Sorry, if they're dividing, you minus the powers. I think I'm going too quick. But a to the power of 0, so anything to the power of 0 is equal to 1. Now, these are like your elementary fundamental ones. Then you have, well, what if you have power on power? So anything to the power of something, then you multiply the powers, m times n. What if there's two terms on the inside? Then the power goes to both of them. Then we also have some fractional indices, which is, well, actually, before we get into it, let's do some negative ones. So a to the power -1 means you flip the fraction. And if it's not -1, like negative n, that means you also flip it, but the numerator is 1, but the denominator becomes positive. So instead of being a to the power minus n now, it becomes positive n. Now, we'll get into some examples in a bit, but you need these, right? It's going to come up a lot. And after you have some index laws, then we also have some of the expansion ones. Now, if you're watching this, make sure you just note these down. So you have anything that looks like this. Like, let's go a plus b whole squared, and then a minus b whole squared. So you have the perfect squares. The way these look is it's going to be a squared plus 2ab plus b squared, and this one's going to be negative. Now, again, the proof of this, and like, it's not very hard to prove, but the proof of this and where it comes from, that's kind of beyond the scope of this video, right? Most of you watching this probably already know the proof. We just forget the formulas and whatnot. So the idea of this, not to conceptually teach you everything, but more so you can quickly, within half an hour, and then doing the worksheet might take another couple of hours, you can go from maybe 60-70% to around 90, okay? And stop making silly mistakes. Then you also have cubics, by the way, right? So the way we expand cubics, if you have a plus b cube, it's a cube. And what happens is the a squares, and the a's go from cube to squared to nothing, and then the b's go from b to b squared to b cubed. And if it's a negative, it's actually the exact same thing, but it alternates. So you get a cube minus 3a squared b plus 3ab squared minus b cubed, like that. And last but not the least, you also have the factorization ones. I probably would just write them down here as well. What happens if you have the difference of two squares or sum and difference of two cubes? These are probably the little bit more advanced, but still very important. A cube plus b cube and a cube minus b cube. This is probably the last thing you need, right? Now, a squared minus b squared, this is the sum and difference of two squares. Most of you guys might already know this, okay? But if you don't know, now you know. And the sum and difference of two cubes, this is rarely taught in really 9 and 10, but really you should know what these are. So if there's a plus, you go a plus b, and then in the middle it's just a squared plus ab plus b squared. If there's a minus, you just put a minus. That's it. And the minus, and this one becomes a squared plus ab plus b squared. Sorry, this one has a minus here. So you can see both these formulas are very similar. It's just that where there's a plus, the plus transfers, the minus goes here. If there's a minus, the minus transfers and the plus goes there. And if you guys are wondering, the proof of this, you kind of expand it yourself. Like a times everything and then minus b times everything. It will simplify to a minus b cubed, or you can just take my word for it for now. So that's pretty much everything you need to know for this worksheet. Then there's some simultaneous and some equations and whatnot, but predominantly, we're going to try to go over all these basic, and then maybe I'll do one basic and one medium question and leave the hard ones to you guys. Okay, so let's try something like this. So this over here, you can see p has a power of 1. If there's no power, it's power of 1. And there's also an imaginary number here, 1. Right, it's not imaginary, but it's there, but we don't write it. And whenever you have something like this, you just multiply the numbers with the numbers. 7 times 1 is 7, and then p to the power of 1 times p to the power of 4 is p to the power of 5. That's it. You add the powers, right? Maybe something a little bit more simple, like this would be p to the power of 9. Cool. And then if they're dividing, let's try something like this. Now, the numbers with the numbers. 12, you can't divide it with anything, so it just stays 12. 12 divided by 1. And then this is going to minus, right? Just remember that. It's not 6 divided by 2, it's 6 minus 2. So that's x to the power of 4, not 3. Then fractions, now this is where everything comes into fruition. Let's try this one. To do this example here, you have to change the last one, the division sign, to multiplication, and you have to rewrite the fraction as, now I don't have a lot of space, I'm just going to rewrite it here, as b squared over 6a. So you flip it. And now you want to start canceling some stuff out. So you can cancel out any of the numerators with any of the denominators. So watch this. Let's see. In the numerator, I have 2 times 9, which is 18. And in the denominator, I have 6 times 3, which is 18. Well, guess what? The numbers all cancel out, literally, right? And you cancel them one by one, right? You cancel out the 2 with the 6, the 9 with the 3, or you can just kind of do this straight away. And then what about the A's? Let's see, how many A's do I have? I have 4 A's here, 1 A here. That's a to the power of 5. And then I have 1 A here, and another A here, and another A here. So I have a times a to the power 4, which is a to the power 5, and then I have a to the power 4 in the denominator. Well, guess what? You have 5 at the top, 4 at the bottom. You're left with just 1a in the numerator. And what about the b's? The b's I have, let's see, I have b to the power 7 here, and the b squared, that's b to the power of 9. In the denominator, I have b cubed plus b to the power 5, which is b to the power of 8. So I have 9 at the top, 8 at the bottom. What's left is just 1 at the top. That's it, right? It looks daunting. The question looks daunting, but really it just takes a minute or two, not even. So, and what if you have something like negative powers or something like this? If you have negative powers, what happens is that the negative goes to both of them. Now, the question does say you have to leave it in positive index. So what I'm going to do first is I'm actually going to like apply the negative, if that kind of makes sense, which is negative means you reciprocate. That's what it means. So I can actually change this to 2q all over 5p to the power of 4 and then squared. Sorry, cubed. And you can see now there's no longer a negative there because I applied the negative, right? So I used up the negative. The negative made the fraction flip. And now what I'm left with is just this. And now the cube just goes to every single term. So it goes 2 cubed, q cubed, all over 5 cubed, and then what is it, q to the power of 4 times 3, which is 12. Cool. Now you can simplify this, like you can write down 2 to the power of 2 cubed is 8 and 5 to 5 cubed is 125, but it's not going to really simplify anything, but you have to make sure your answers are fully simplified. And then we have some fraction ones. These are some challenging ones, right? I'll let you guys try this because there's some fractions involved. Now, this is where things become a little bit freaky. So let's do this one here. Now, we're applying pretty much all the index laws here, right? If not most of them. You have a fourth root this time. If you have something that has a fourth root, square root, cube root, whatever. So a to the power square root of a, this is equal to a to the power of a half. So you can rewrite it as a fraction in the power. We call these fractional indices. And then if it's a cube root, that becomes, hopefully you guys get the idea, 1 over 3. And then if it's the nth root, so it doesn't matter what the number is, the general formula is a to the power 1 over n, like that. What if it has a power? So if it's something like this, a to the power of m over the square root of n, this actually is just a to the power of m to the power of 1 over n. Same thing. But you can multiply the powers, right? Power and power we multiply. So that becomes a to the power of m over n, and you can just straight jump to that. So we're going to be using this here. So for this question, I have the fourth root. So what I'm going to do is this actually becomes a quarter, right? This becomes the power of a quarter. So I'm going to rewrite this as x to the power of 8 all over y to the power of 12 times minus 3 over 4. Because that's what a quarter times minus 3 is. Now I'm going to read the question. Does it say positive indices? Yes, it does. Okay. So that means this can't be negative. What I'm going to do is I'm going to apply the negative, if you will, right? I'm going to flip the fraction. Again, this is not the only way to do this. We can do this different ways or in a different order. So that's y to the power of 12 and then x to the power of 8. All of this to the power of 3 over 4. And then it goes power on power. So you go this times this and this times that. And what that gives you is what's 12 times 3 over 4? That's 9. It's y to the power of 9. And then 8 to the power of 3 over 4 is x to the power of 6. Okay? So I just multiplied the fractions in my head and Bob's your uncle, right? Because 4 times this cancels out and you get 9. Cool. But the main thing you have to remember is this formula here. Okay. Is that if you have a power and you have a surd, you can simplify it to the power goes in the numerator and then the root. So if it's the nth root, fifth root, sixth root, it goes in the denominator. Okay, cool. And that gives you a strong foundation to do quite a few of these questions. Then we have some more challenging ones. Let's move on to expansions. I already went over the laws, but for the first time you're doing it, you are going to, you probably want to just write down the entire thing properly. So it's x squared plus 2 times 1 times x plus 1 squared, which is x squared plus 2x plus 1. And then by the time you do a couple of these, you'll start noticing a formula, right? And you'll be able to do these in your head straight away in like one line. This is now t squared plus 6t plus 9, right? So the formula, if you guys remember, the first term squared, and then 2 times these two terms, so 2 times t times 3, and then it's the last term squared, so 3 squared. Now, this is a little bit more challenging. So now if you have something like this, where the number up front is no longer just t or x, now it's 3t. So you have to be a little bit more careful. So this is going to become the first term squared, which is 9t squared. So again, formula is the same. First term squared minus 2 times the first term and last term. So you have this 3t times 4 is 12t, and then 12t times 2 is 24t. And then it's the last term squared, which is 16. Same formula, just the terms are a little bit different. Okay. And then we move on to, we have some difference of two squares. So different two squares, every single one of them are exactly the same. You have to be able to recognize them, right? So even if it was some like smiley face plus sad face times smiley face minus sad face is equal to smiley face squared minus sad face squared. Okay, so something like this, pretty simple, is t squared minus 144. That's it. Sometimes it might get a little bit funky. So something like this one here is now 5k squared, which is 25k squared, and then you have 6 squared, so that's minus 36. Cool. Not too shabby, if I say so myself. Then you have the cubic ones. Highly recommend practicing these. Once you become decent at them, it's sometimes a bit hard to do in one line, and that's okay, right? There's no points for doing it in one line or two line. You just want to get it correct. That's the goal. So this is p cubed plus 3 times the first term squared times 6. Then it's 3 times the first term by itself, but the second term squared, and then it's the last term cube. And then you want to simplify this. So that's p cubed plus 3 times 6. What's that going to give me? 18p squared plus 6 squared is 36. 36 times 3, what's that? 108. Just gonna double check that. Obviously, I don't need to double check because I'm pretty much always right. Yep. And then times p, and then the last term 6 cubed is I think it's 216. Again, I'll double check, but obviously I am right. All right, cool. That's it. All right. Once you might be able to do some of these in your head, but again, just try not to do them when you're first doing it. For the first time, just do it in 2 lines. That's okay. And then maybe the next ones you can try, right? Even though they actually get a little bit harder. So that's how you expand cubics and squares, and we have some miscellaneous ones. Like these are your real challenge questions, because you have to be able to recognize which formula to use and how to do it with no context, right? Over here you have context. You know it's a cubic, right? You know these are cubics, and you know the previous one's a difference of 2 squares. But these are your real questions. This is like a quiz almost, because in an exam they're not going to tell you use the how to expand a cube formula or use the difference of 2 squares. You have to know which one to use when you see these. Cool. Then we have some more miscellaneous ones as well. If you have multiple brackets, just multiply 2, and then do that again. We have some nice challenge questions here. I'll leave them to you guys, but you know, this is a very common one, fun one, really, right? If you have something like this, what is it? It's the first term squared. Now, if you're like, you know, if you know this, what's going to happen when you square and square root something? They cancel out, right? It's like the opposite thing. So I already know this is going to be the first term squared is just x. Then it's 2 times the first term and the last term. Boom, these two cancel out, right? That's the first term and last term. So you're just left with 2 in the middle. And then the last term squared is just 1 over square root of x squared, which just cancels out again, right? It's actually very more common than you think in harder questions. But yeah, practice these, right? Nothing too crazy. Like, this is a cool question. This is also a very cool question. I'll give you a hint if you're watching this anyway, is to square both sides. Okay, that's my hint. And you'll see something magical is going to happen. But I'm going to keep this fairly simple. Let's move on to factorization now. Now, for the factorization part, we are trying to do the opposite of this, which is, if you look at this guy here, I can rewrite this as a squared minus 2 times 6 times a plus 6 squared. Now, what does that look like? It's actually the opposite of what we just learned, right? And that's what factorization is. You're trying to go backwards, right? It's the opposite of expanding. And if you have something in this form, I already know straight away this is a minus 6 whole squared. Because if someone asked me to expand a minus 6 whole squared, what is that? That's the first term squared. Then it's minus 2 times these two, which is that. Then it's the last term squared. Cool. So this is just like more recognition. It's like, do it fast, recognize which one it is, and like you'll be able to do it straight away. This I know is r minus 20 squared. Boom. Okay. Now, what if it's not a nice number, right? Something like this. And this is where things get a little spicy. Okay. These ones, let's do now I want to do this one's all right. Maybe something like, I want to do ones with a number at the front. Let's try, I have space here. Let's do this one. Now, this one's a little bit different because, well, what's the first term? Well, I think the first term is 11x squared, right? Okay, that's cool. The middle term is, well, I know it's a quadratic, so it really should be 2 times something, right? So it's going to be like 2 times, well, if I pick the first term, that's 2 times 11x, that's 22. And then, well, 22 times 2 then gives me 44. And then it's the last term squared is 2 squared. Well, surprise, surprise, we actually have a perfect a perfect square. We call these perfect squares when they can be rewritten like this. Fun stuff. Now, you have a difference of 2 squares here, right? It's just the opposite of what we did. Let's try something like this. This, I believe, is going to be d minus 16 and d plus 16, as this is 16 squared. I'm just going to quickly check that. And yes, of course, that's 16 squared. Very straightforward. You can do all of these now. Moving on to cubics. Now, I already gave you guys a formula, but we have to just be able to recognize is what the cubes are. So, for example, the last one is 3x cubed minus 4 cubed. So now you have the difference of 2 cubes. So that's a cubed minus b cubed, which is a formula. What is that? A cubed minus b cubed is a minus b, bracket, a squared plus ab, so that's 3 times 4, 12, and then plus b squared, 16, right? The formula we wrote up there before. Right, that's pretty much it. And then you can practice some more. And when you have something like this, you want to do group factorization. You have to, if you can recognize, like this is actually a cubic, right? Once you become decent at these, you can kind of recognize it straight away. Like this is going to be, if I was to put my money, 2a minus 3b cubed. And let's see if it actually is, because first term cubed minus 3 times the first term squared times the next term plus 3 times the first term times the next term squared plus the last term cubed. And that's exactly what it is, right? 3 times 2 squared times 3. Now, my handwriting's a little bit off here, but that's 3. If you look at the numbers, it's 3, 2 squared, and 3. Yeah, that's 36. And then 54 is 3 times 2 is 6, and then this is times 9. Yeah, that's 54. So it works out. But again, this is just the reverse of the expansions. You already know what the formulas are. You have some more difference of 2 squares, some fun factorization, some fun stuff. You know, maybe a little miscellaneous. And let's see, this is some basic factorization. Let's go over maybe one of these. I think a very important one is what happens if you have a negative, right? Comes up very often. If you have a negative in both terms, you want to factorize a negative out, right? And they also both have an a in them. So what's left? If I take a minus a out of an a, I'm left with a. And if I take a minus a out of a minus ac, I'm left with a c. And what you want to do is you want to quickly double check this. Minus a times a, is that minus a squared? Yes. Minus a times c, that's minus ac, correct. And sometimes you might have to force factorize a negative out. I want to force factorize a negative x. What am I left with if I take a negative x out of a negative x squared? I'm left with just an x. And if I take a negative x out of a positive xy, well, the x is gone, there's a y left, but the x also becomes negative. That term, sorry, becomes negative, and we can actually double check this by just expanding it. What's minus x times x? Is that minus x squared? Yes. And what's minus x times minus y? That's positive xy. Cool beans? Not too shabby. And then you can practice this, right? Force factorize the negative there as well. We've got some fraction work, nothing crazy. Questions like this where you have 4 expressions, what you want to do is something we call group factorization. So what that means is you factorize these 2 terms and these 2 terms. So the first 2. So what's common in the first 2? What's common in the first 2 is a, and you're left with c minus d. Then what's common in the next 2? A b, and you're left with c minus d. And more than likely, these 2 brackets are going to be the same. So now what you want to do is you want to factorize from the entire expression. The entire expression has a c minus d in common, right? The entire expression. So they both have a c minus d. Yeah, they both have a c minus d, c minus d. And then what's left? Well, what's left is, well, I'm just going to highlight it, or just underline it, is a and a plus b. And voila, that's your answer. So practice these ones as well. Then we have some, I think I want to go over quadratic expansion before we move on. Okay, so I want to just leave this till the end. But what if you have something like this, right? This one, you can't really do anything with it. Like, it's not x plus 3 whole squared, is it? Because x plus 3 whole squared is x squared plus 6x plus 9. It's not x plus 2 whole squared. X plus 2 whole squared is x plus 4x plus 4. So what is this? Now, I'm going to do this right in this corner. If you have something that looks like this, x minus x plus a times, let's say, x plus b. So it's not x plus a whole squared or x plus y whole squared. But if it looks something like this, let's expand it. So x times x gives you x squared. Then you have x times b gives you xb, or let's just say bx. And then a times these 2 gives you ax plus ab. I'm going to just factorize the middle 2 out. So you have a plus b times x plus ab. Now, what you want to notice here, right, it's just a quick explanation, even though it's not the intention of this video, is that, yeah, we had a and b here, yeah, a and b. The middle term actually just became the sum of those 2 terms, whatever a and b was, and the last term became the product. So you just multiplied them. And that's actually what we're going to be looking for. What we're going to be looking for is, what 2 numbers add up to this? They give me a sum of 6 and a sum of 5 and a product of 6. Well, those 2 numbers, I think you can kind of guess it's 2 and 3, right? Because what's x plus 2 and then x plus 3? And if you expand that like really quickly in your head, right? What's the last term? 2 times 3, 6. Okay, the first term is x times x, x squared. And what about the middle terms? 2x, 2 times x is 2x, x times 3 is 3x, and boom, that gives you 5x. So I know I got the right answer. And you can practice some of these on your own, right? Pretty fun, right? You're looking for 2 numbers and multiply to give you minus 35, add to give you 2. I know that's x plus 7, and then x minus 5. It becomes actually pretty fun. Now, it's all fun and games till you have a number at the front. So quadratics that look like this, there's like a 1 here, right? We call these monic quadratics, or monic quadratics. Comes from the word mono, which means 1. Whereas here, if you have a number at the front, now they're non-monic, which means they don't have a 1 at the front. And the way you do this is like 1 extra step, just 1. I'll do this one here. The extra step is you're looking for 2 numbers that multiply to give you, actually I'll write down what you do. So 3a squared minus 5, right? I'm going to leave that there. You're looking for 2 numbers that still add to give you minus 14, right? But not multiply to give you 5 anymore. Now it's actually that multiply to give you minus 15. That's what you're trying to do. That's 1 extra step. And you actually break down the middle term into these 2 terms. So what 2 numbers add to give me this and multiply to give me this? That's going to be, so add to give me minus, so it's going to be minus 15 and plus 1. Okay, so minus 15 times 1 is minus 15. Minus 15 plus 1 is minus 14. Okay. And then what I'm going to do is I'm going to write down x in front of these. So once you find these two numbers, you put an x there. Now, I want you to notice something here. We actually didn't change anything. What's the middle term? Oh, sorry, it's not x, it's a. But what's the middle term? The middle term is minus 14a. What's the middle term here? What's minus 15a plus a? It's also minus 14a. I didn't change anything, right? I just broke down the middle term into the two things that we found. And now what you do is the same thing. You do the exact same thing that you did with whenever you had 4 terms before, which is you do group factorization. What's common in the first two? What's common is a 3a. And then what's left? You're left with an a minus 5. And then what's common in the next two? Now the next two have nothing in common, so I'm just going to write down a minus 5. That's it. And they only have like a 1 in common. Okay. Now I'm going to factorize the entire expression. What do they all have in common? Well, the entire expression has an a minus 5 in it, correct? So I'm going to write down a minus 5. And then all I'm going to do is write down what's left. What's left is a 3a and a plus 1. Cool. Now, there is actually a way to do this in like one line. It's like a fraction method, but I'll leave that for the Algebra Workshop that's live in person. What else do we have? Oh, I think this is, no, that's not from before. This is also not from before. Okay. That's all of that. Factorization done. I give you guys some practice. These are some cool questions. They're very hard, like they're hard-ish, like not very, very hard, but if you can do them, that's great. If you can't, it's not the end of the world, okay? Because the goal is to get rid of silly mistakes. But I just add some fun, hard questions here and there for those who wanted it. I think for one thing for fractions, by the way, just remember, you can cancel out any of the numerators with any of the denominators. If you just remember that, as long as they're all multiplying, so the x and x cancel out, and that's it. Then your answer is 5y over 4. Okay, very straightforward questions. For ones that are adding and minusing, you have to make sure the denominators are the same. So to make this 6, I'm going to multiply this by 3 and 3. So that gives me now 3x over 6 minus x over 6. And now I can cancel out the numerators. 3x, not cancel out, sorry, but you can simplify this. So this becomes 3x minus x all over 6, which voila, is x over 6. And then boom, cancel these two out and you're left with x over 3. Okay. Then this is the fun stuff. I was trying to get to this. Now, algebraic fractions, but now you have multiplication involved, but you have powers, you have indices. Well, it's very similar to a question we did before, but this time we are going to, let's cancel out some numbers. Well, I can cancel out the 15 and the 5. That gives me 3. I like to work with the numbers first. I can cancel out the 3 and the 6. That gives me 2. I can cancel the 2 and the 24. That gives me 12. That's it. What about the m's? Okay, I have m cubed here, and I have m times m squared in the denominator. I have 3. 3 in the numerator, 3 in the denominator. They cancel out. What about the n's? I have 4 n's in the numerator, and I have 1 n in the denominator. Well, I'm just going to be left with n cubed. That's it. Easy peasy. Really takes like 10 seconds. So then we have some plus and minus, combining everything together. I'm sure you guys got this. Then we have some fun algebra questions. Let's move on to some surds now. Now, surds, very simple. Like, let's actually do some laws here. So, if I was to give you like x plus 3x, that's 4x, correct? Well, what do you think is root 2 plus 3 root 2? Well, it's 4 root 2. That's it, right? Like, it works the same as algebra works. So, like something as simple as like this one, 2 root 11 plus 6 root 11. Is a root 11, like that. And not only that, if you have, sometimes you might have to simplify it first. So if I give you something like root, let's go root, it's like root. Now root 20 is the same thing as root 4 times root 5, because you can reverse it, like if you can multiply the insides. And the reason why you need to do this sometimes, or if not all the times, is that you can simplify this. Root 4 is actually just 2. So root 20 is actually 2 root 5. And if you have the 8200 AU, that actually simplifies it for you. If you have another calculator, like the 82 AU, that won't. It'll give you like a decimal. So root 20 is 4.47. Okay, so then for some of these, you'll have to simplify it first. Like let's do, well, if I was to do this one, for example, like root 45 is root 9 times root 5, which is 3 root 5. Now combining the 2 or 3 things that we just learned, you can do a question like, I'll just do part X. Now, root 75. Now, once you do enough of these, you can like get it straight away. Root 75 is 25 times 3. So I know this is 5 root 3. And then root 12 is 4 times 3. So I know this is 2 root 3. And then boom, your answer is 3 root 3. Fun stuff. Practice these, they're really good. Then when you multiply them, just remember when you multiply the number with the number, right? And the surd with the surd. You can simplify it first, obviously, but I'll do this as an example. So see 72. 72 I know is, what's the highest one I can take out? Is it divisible by 16 maybe? 72, I don't think so. No. 72, the highest one I can take, I think it's 36 times 2. Yeah. All right. So I can change this to 10 times root 36 times root 2 multiplied by 5 root 2, like that. Now watch this. It actually becomes a very nice number because root 36 is just 6. And then root 2 times root 2 is just 2. And there's a couple of explanations for this. Well, root 2 times root 2 is, well, if you multiply the insides, that's root 4, that's 2. Another way you can think of it is root 2 times root 2 is root 2 squared, which hence means they cancel out. So, well then, I'm just left with multiplication here. 10 times 6 is 30. 30 times 2 is 60, and then 60 times 5 is 100, and 60 times 5, 300, I think, yeah. Okay, hopefully I didn't make a calculation error in my head, but that's it. Nice numbers. One thing to remember for brackets, by the way, remember, don't forget it's this times this times that, right? Call it the eyebrow method. Okay. Keep going. Now these are some harder ones, so for challenging ones, but only do them once you get 100% in the easier ones. Simultaneous equations, one of my favorite topics. If you're asked to do simultaneous, now it says using substitution, that means you have to make one of them the subject. Let's try one. I'll do part double I. So I'll do part double I with like perfection. What I'm going to do is I'm going to let the first one, be equation A. So the first one, y is equal to x plus 1. And I'm going to let the next one be, I'm going to let that be x plus y is equal to 5. Now, when you're using substitution, one of them has to be the subject. You see how y is the subject here? What I'm going to do is I'm going to sub in y is equal to x plus 1 into equation B. Now, that means I'm going to change this to that because that's what y is, right? Y is x plus 1. And what you get is, okay, you get x plus y plus 1. Sorry, x plus 1 is equal to 5. And then you simplify this. You get 2x plus 1 is equal to 5. That becomes a basic equation. And you're going to get what? 2x is equal to 4. So therefore, x is equal to 2. Cool? And then once you get one of them, then you just use any one of the equations to find the rest. So therefore, now I'm going to sub in. I want to sub in next step. So I don't have the craziest amount of space here. I'm going to sub in x is equal to 2 into the first one. It's a lot simpler. And what you get is y is equal to 2 plus 1, which is 3. And that's it. Right? Very easy if you know what you're doing. Let's keep going. Now, you can try a bunch of these more substitution ones. They get a little bit harder. Some of them, you can see here, you can't substitute straight away. You have to make y or x the subject first, and then substitute. Give them a try. You can use elimination as well, by the way. So I think I'll do one elimination one, only because it's so satisfying. Let's do something like, let's do this one here. Okay, this one has a couple of layers to it. I like this one. So I'm gonna write this down as A. So equation A is 7x plus 2y is equal to 5. But for the second one, I'm actually going to divide the entire expression by 3. Okay? You don't have to do this, but I'm going to. And what you get is 3x minus y is equal to 11. That's my new expression. So this is equation B. Now you probably want to, when you're working this out in an exam, like you want to like write down exactly what you're doing, okay? But I'm explaining to you as I go. I'm not in an exam, okay? Now, what I'm gonna do is I'm actually gonna multiply this equation by 2. So B times 2. And what that's gonna give me, so I'm gonna write this again as equation number C, is when I multiply it by 2, you're going to get 18x minus 3y, so minus 2y, is equal to 22. I have to remember the equation in my head. I don't know why I rubbed it off. So, and sorry, this was 6, because it was 3 there. Now, the reason why I did that is because now what you can do is you can actually add these two equations, and you're allowed to do that. You're allowed to add equations, right? And you probably want to, again, write down exactly what you're doing. Equation A plus equation C. And this is a little bit higher level stuff, right? Simultaneous equations is you're trying to solve for two things missing, X and Y. But you can't do that. You can only solve questions there's only one thing missing, which means you have to reduce it from 2 to 1 thing missing. And if you just add these two, this is what you get. What's 7x plus 6x? That's 13x. But what's plus 2y minus 2y? It cancels out. And look at that. Now you only have one thing missing. And then 5 plus 22, what does that give you? 27. And therefore, x is equal to, what is that? 27 over 13. Okay? Now, this was the whole point. The whole point was so you can get one of them. And now you can just sub it in. Now just sub this into there or sub it into there and make y the subject. That becomes easy. But this is the first part that you have to know. Cool? Okay, moving on to some third one. These ones are really fun. This is probably one of my favorite questions, to be honest. But when you have something like this, I'll give you guys a clue, like what it is, right? It's you have to equate the rational numbers, so these ones here, with whatever is rational. Now, actually, I'll give you an easy one. So like this one here, let's probably start off with this. This is the easier one. So you equate the rationals with the rationals and the irrationals with the irrationals, and that's how you solve them. Okay, so you have to do this is a hard one. If you want to make your life a little easier, you can change this to x plus 6. But yeah, these are fun questions. And the way you want to do this is once you write down your working out, so you go like x plus. So this one, for example, like it would be x minus 3 is equal to minus 1, and boom, you get your answer. X is equal to, what is that? 2. And then y is also going to be, it's like whatever's inside the third. Y plus 2 is equal to 5. Cool? But they're not going to be as simple. That's a very simple one. Love these ones, like this one, they're going to be simultaneous equations. So it's going to be a little bit tougher. Let's keep going. Then we have triple simultaneous. Now, this one is, like, this is as hard as it gets, really, for simultaneous. Most of them are, like, most questions you do get double, but if you get triple ones, especially if you're in 10 or 11, like they get a page long. Like these questions, you have to reduce it from 3 equations to 2 equations to 1 equation, and then you solve it. So it's a long one, but I'll let you guys figure it out. Like it's like, I'll give you guys the trick away, okay? This is how you do these questions. You want to find 2 equations where you can add and it cancels out. So for those of you who are watching this is what I would do. Let's call this equation 1 and call this equation 2. Here's my clue. Just add equation 1 and 2. When you add them, the plus z and the minus z will disappear, right? And you'll be left with just x and y. And try to find another equation maybe you can make by adding these two or adding these two, and you'll find another equation in terms of x and y, and then it becomes double simultaneous. So triple simultaneous is just one layer on top. You're trying to reduce it to 3 things missing to then 2 things missing, x and y, and then from that to 1 thing missing, and you'll get an equation. And once you have 1 thing missing, you can then solve it, because you can't solve equations where there's 2 things missing. If I say x plus y is equal to 10, like there's infinite answers: 1 and 9, 1.1, 8.9, 2 and 8, right? 0.1 and 9.9, like there's infinite answers. But as soon as I give you, okay, if I say x plus y is 10, but like x minus y is equal to 4, now there is a set of answers, right? It's like 1. Well, what is it? It's actually going to be, I think you can do it in your head. It's 7 and 3, right? 7 plus 3, 10, 7 minus 3, 4. But you can't do that if it's just x plus y. Okay, then we have some hard ones. These are hard ones, but give them a try if you want to. I want to keep going over the basics. Ooh, inequalities. This is always fun. Now, in inequalities, there's two main rules you have to know. If I say that 3 is greater than 2, and I multiply both sides by -1, or any negative number, then this becomes -3, and this is -2. Now, what happened? -2 is actually bigger than -3, right? Because on a number line, -2, 0, and -3. -2 is bigger. So what happens is that the sign flips. And another one, this is less common, but if I say 3 is less than 4, then I reciprocate both sides. So I go 1/3, and let's say I reciprocate both sides. This is 1/4. Sorry, so I flip both sides. Well, 1/3 is actually bigger than 1/4. Okay? And these are the main two rules you have to remember. Is if you multiply both sides by a negative number, or you reciprocate both sides. That's when the sign flips. If you remember that, you remember everything else. That's pretty much it. So if I was to give you a question like, let's say something like this guy here. No, it's too easy. Let's go this one. Part triple I. What I'm going to do first is take the 9 to the other side, or I'm going to minus both sides by 9. Same thing. And what's that going to give me is -2x is less than 17 minus 9, that's 8. And then I'm going to divide both sides by -2. So this is where you have to be careful. Because if I don't divide both sides by negative number, it's going to change. 2x is greater than -4. That's it. Okay, fairly straightforward. It's just like equations, but just in inequality form. Let you guys practice. If it's triple, just make sure you do things to all 3 sides instead of 2 sides. So now you're going to multiply all sides by 3 and minus all sides by 4 after that, and then divide everything by -5. But again, the scope of this video is to go over the easier stuff. And let's see. Now, quadratic inequalities, you have to graph them. You can't do them without graphing. Or at least it's very fast with graphing. So if you know how to graph parabolas, then you can do this. If you can't, that's okay. It is kind of high level. Put that in there for those who've done quadratics. And that's pretty much it. Then we have some terms of use, but that is a big chunk of the algebra that you need. And if you want to know how we do this in person live, it's like we have a whole 8-hour thing that we do with all of our students, and it's an algebra workshop, and we go over pretty much all the algebra you need all the way till year 12. So it has even more than this and it's live, it's interactive. You can ask questions, and we'll have exams and quizzes, and we'll go over what your weaknesses are, and me and my team will look at how you do your working out and help you. If that's something that's of interest to you, then there's going to be a link somewhere here. Sign up, and I'll see you in person.